Out in the vast oceans, where the mightiest vessels of modern naval power hold their ground, the United States Navy's aircraft carriers often appear like floating cities. These enormous warships are the core of American maritime dominance, and every detail of their structure is engineered with precision. Among the most overlooked yet crucial aspects of their design are their anchors. While most people focus on the fighter jets on deck, the nuclear reactors below, or the defensive weapons surrounding the carrier, very few stop to consider the massive anchors that keep these leviathans steady when required. What makes this detail even more fascinating is how these anchors must deal with intruding elements such as marine growth, debris, or even man-made interference, and how the Navy ensures that their performance remains flawless despite operating in some of the harshest environments on Earth. U.S. aircraft carrier is not like an ordinary ship that can casually drop anchor in a bay or shallow waters. These vessels displace over 100,000 tons, and their anchors weigh in the tens of thousands of pounds. Each anchor chain link alone can be as large as a human torso, forged from high-strength steel, capable of withstanding tremendous stress. When a carrier drops anchor, it doesn't just hold the ship. It resists powerful ocean currents, tidal forces, and the inertia of a steel giant longer than 3 football fields. But the challenge isn't only about weight and strength. Over time, marine environments introduce countless intruding elements. From barnacles and algae to discarded fishing gear, sand, or even intentional sabotage attempts. The Navy must have systems in place to ensure these intrusions never compromise the ship's readiness. The first line of defense comes from design. The anchors are streamlined and forged to minimize surfaces where marine organisms can latch on. Their size alone makes them intimidating. But more importantly, they are built for smooth operation. The shank, flukes, and crown of the anchor are all shaped to dig effectively into the seabed, while resisting unnecessary fouling. Still, no design can entirely prevent nature from doing what it does best. Saltwater is unforgiving, and marine life sees every structure as potential real estate. That's why these anchors are routinely treated with protective coatings, including specialized anti-fouling paints that slow down the buildup of barnacles and other growth. This reduces drag when raising the anchor and keeps the mechanisms from jamming due to organic buildup the anchor chains. However, face their own set of issues. Each link is enormous, but the spaces between them can become traps for seaweed, ropes, or even fishing nets drifting in the ocean. Imagine raising a chain where, in addition to its immense weight, tons of soggy kelp or nylon ropes have tangled themselves around it. This could potentially add significant strain on the winch system and delay operations. To combat this, the Navy employs regular inspections using divers or remotely operated vehicles. Divers are trained to clear entanglements and assess damage, though in contested waters, such operations become risky. In those cases, mechanical solutions like chain scrapers or Hyper-S or water jets may be deployed to remove obstructions. Before the anchor is retrieved, there's also the problem of silt and sand. When an anchor is buried deep into the seabed, it can bring up large amounts of sediment when lifted. This mud can cling to the flukes and chain, making them slippery and adding excess load. To counteract this, naval procedures often include rinsing the anchor chain with seawater as it is hauled up. High-volume washdown systems are mounted near the hawse pipe, blasting away mud, seaweed, and debris before the chain is fully stowed. It's a simple yet effective process, ensuring the anchor locker doesn't get clogged with muck that could later harden and cause operational headaches. A more concerning issue is man-made intrusion. In some parts of the world, adversaries or saboteurs may attempt to tamper with a carrier's anchoring system. While direct sabotage of an aircraft carrier is extremely rare, the Navy takes no chances. The chain lockers and anchor gear are heavily secured, with constant monitoring. Security teams, sonar, surveillance, and even anti-diver measures ensure that no one can stealthily approach and interfere with the anchor system. Additionally, if an anchor were ever deliberately fouled with foreign objects, the Navy has the tools and expertise to cut away or neutralize the obstruction quickly in extreme scenarios. Carriers can rely on tugboats or even reposition under their own power using nuclear propulsion, making them far less vulnerable than conventional ships. What truly sets apart the way U.S. carriers deal with intruding elements is the combination of brute strength and precision engineering. The windlasses and capstans that handle the anchor chains are hydraulic or electric-powered machines capable of exerting thousands of pounds of force continuously. These systems are not just about lifting the anchor. They are about overcoming whatever resistance the ocean might have attached to it. The gears, brakes, and clutches are designed with redundancy, ensuring that even under strain from added fouling, the mechanism won't fail. This reliability is critical because a malfunctioning anchor could put the entire carrier at risk. Especially in congested or hostile waters, the crew assigned to anchoring operations are also highly trained. For them, dropping and retrieving the anchor is not just routine. It is a carefully orchestrated They monitor the chain, listen for unusual sounds, and watch for irregular tension that could indicate something has intruded. If the anchor sticks or comes up fouled, procedures are immediately enacted to deal with the obstruction safely and efficiently. This human factor, combined with engineering excellence, is what allows the Navy to manage challenges that would cripple lesser ships. Another layer of defense lies in maintenance. Anchors and chains are periodically removed during dry docking periods. Shipyard crews then inspect every component, removing corrosion, replacing damaged links, and reapplying protective coatings. This ensures that no long-term buildup of intruding elements ever has a chance to compromise the system. It's a cycle of constant care and renewal. Part of what keeps carriers operational for decades despite the relentless abuse of saltwater environments. From a broader perspective, the way aircraft carriers deal with intruding elements on their anchors reflects the philosophy of naval engineering itself. Every problem has to be anticipated, and every solution must be robust enough to function in wartime conditions. A commercial ship might accept delays or inconveniences due to fouled anchors, but a U.S. carrier doesn't have that luxury. Its mission could involve rapid deployment, evacuation, or power projection. And delays of even minutes could have serious consequences. That is why their systems are designed to not only resist nature, but to dominate it. Even the storage of the anchors has been engineered with these challenges in mind. When hauled up, the anchor doesn't simply hang loose. It is pulled tightly into the hawse pipe, and any residual fouling is scraped or flushed away. This keeps the anchor from rattling, reduces wear on the chain, and ensures that no hidden debris makes its way inside the ship. Some modern systems even incorporate sensors to monitor strain and detect obstructions, alerting crews before a problem escalates. In addition, the Navy continuously studies new materials and coatings to reduce advanced polymers, ceramic coatings, and even electrostatic systems are being tested to make anchors less attractive to marine organisms. The research may sound small compared to the grand scale of carrier aviation or missile defense, but it represents the Navy's holistic approach. Every part of the ship, no matter how seemingly minor, is given attention because the reliability of the whole depends on the performance of every individual component. For the casual observer, it might seem surprising that so much thought goes into something as ordinary as an anchor. Yet, on a vessel as massive and strategically important as a U.S. aircraft carrier, there is no such thing as a minor detail. Anchors represent security when nuclear-powered giants pause in a bay or near a coast. Their reliability ensures that carriers can hold position in unpredictable waters without drifting into danger, and their ability to shrug off intruding elements, whether natural or artificial. A testament to American naval engineering.